Hello and welcome everyone. Thank you for joining us in today's webinar. A very good morning to all our friends from overseas and a good evening for all our Indian audience that has joined in today. My name is Bismay Mohapatra. I am the product manager at Tatvik Analytics. In brief, Tatvik is an authorized Google partner for Google Analytics 360 suite and is also one of the leading providers of digital analytics consulting for SMEs and large-scale enterprises. We are also excel in predictive analytics and data science solutions for most of our enterprise clients. So today's webinar is on web and app feature optimization using Markov model. It shall be presented by my colleague. His name is Aditya Thakkar. He works as a solution engineer here at Tatvik. Just a few things before we get started. If you have any questions during the presentation, please type them into the presentation box in your GoToWebinar control panel. I will bring them up at the end of presentation and will be sure to answer as many questions as time permits. I'll also be carrying out a couple of polls during the presentation. That too will help us know you guys better. We have a great audience joining us today here. Quite a good names that I can recognize from my last few webinars. A huge shout out for you guys again. Now, without any further ado, I will turn this session over to Aditya.
Thank you for the introduction. I'm really excited for this webinar, and we are looking for a great session ahead. So here are the outlines of the webinars that we will have today. So we'll start with a quick introduction to the Markov modeling. Then we will see that how this Markov model can fit into our world of digital analytics. Now, later on, we will also see a concrete example of Markov model for an e-commerce store. Now, once we will have the Markov model for an e-commerce store, we will try to bring out the insights for the Markov model. So, and lastly, we will cover what are the advanced objectives for which Markov model can be used. So let's get started. So before we talk about what is Markov model, let's talk about digital analytics or digital marketing. Now, I am really interested in, as a digital marketer, we sort of run two types of analysis, two types of campaigns. That is, one is a user acquisition campaigns and another user retention campaigns. Now, what I am interested here in knowing is that what percentage of your campaigns are directed towards new user acquisition campaigns. So, Bishma, can you help me in running a poll where we can find the statistics?
Sure, I'll just launch the poll. I will request the audience to please share their answers on this. So you were, Aditya, you were talking about the user acquisition campaigns. So is it like Markov modeling has something to do with user acquisition campaigns, or is it for user retention campaigns? How is it? Would you give us a little insight into that?
Yeah, sure, Vishnu. So the Markov model has more to do with the new user acquisition campaigns, because we'll try to figure out that how our user or how our features of our website can affect the newly acquired users, or how it can change the behavior of the users that we have acquired. So yes, that has all to do with the new user acquisition campaigns.
Okay. I think we have a fair amount of audience answering our polls. I'm just giving last 5 seconds before we close the poll. I'm going to close the poll. Yeah, I'll share you the results, Aditya, so that you can use them during our presentation. Yeah, so 67% are saying that they do have less than 25% for their campaign budget, and 33% they say that they have greater than 50%. Seems a very clear winner here, right, Aditya?
Yeah, Vishme, that's pretty interesting stats to start with. So what we as a digital marketers we do once we have ran all these campaigns, what we do. So the very obvious next step is that we measure the efficiency of the campaigns, or we try to figure out how our campaigns have performed. So and based on those performances we try to take the corresponding actions on those. So for an example, there might be some campaigns who did well, and some campaigns may haven't performed well. So what we do is we try to manage our spendings on those campaigns. We increase our spendings for the campaigns that have done well, and we try to reduce or sort of stop our spendings on the campaigns that haven't performed. But there is a slight twist here. What about the campaigns that have brought the quality audience, yet they have failed to perform well? Or what about, or let's say, the campaign is bringing the users, yet the users are leaving the property as soon as they come, or they bounces back. So what can be the reasons? Well, there can be n number of reasons for the why users are bouncing, and one of them can be the website features or app features are not smooth enough to engage the user, or they are not easy enough for a user to make the purchase or to download the stuff they want to do. So via Markov model, we will try to figure out how greatly this the features of our website can impact the user conversion. So we will do it using the Markov model. So that brings us to what's called the Markov model. So here is the definition of a Markov model, which says a Markov model is a stochastic model used to model randomly changing systems where it is assumed that the future state depend only on the current state, not on the events that occurred before. Now that's the definition, and yeah, I would say the same. What was that? Even I didn't understood the definition. So let's try to understand what is Markov model in more simpler terms. So Markov model consists of three things. That is state, transition, and rate parameter. A state is a possible states of the system, or we can say where the user is currently in his or her journey. A transition is a possible transition between these states. So it is like simply a possible paths a user can take from one state to another. For an example, if I am at a state A, and there are possible paths from state A to state B, state C, state N, from A to state B, C, and D. So there are three transitions that I can take. And lastly, the rate parameter. It is a metric which represents the rate at which the transitions happens, or it is the magnitude of each of the transitions between those states. So let's try to visualize our model, or what is a Markov model. So if you see in our graph that there are three nodes or vertices labeled S1, S2, and S3, and there are four edges. Now visually there are only three edges, but if we look closely, the edge between S2 and S3, they are bidirectional, which means in total there are four edges. So, and with each edge we have a number associated with it, which is represented by X. So the Markov model is like S1, S2, and S3 are the states, and the edges, and the X as the rate parameter for each of the edge. Now that's enough of the theory, the nodes and edges and rate parameter. Now let's try to chip this model into the context of digital analytics or digital marketing. So how it can fit into our world of digital marketing? Well, for an e-commerce, let's just try to understand with the help of the use cases. For an example, for an e-commerce store, the features or the states of the system can be navigation, filter, search, delivery checker, and many more. And the edges or the transitions for an e-commerce store can be the paths that user can take from between those features. For an example, user can go from navigation to filter, filter to search, search to filter, and from navigation to search. Similarly, for an lead gen website, there also we can define the features and a journey between those features for an user. For this Markov model that you can see on the screen right now is a Markov model for one of our lead gen client, where there are three options via which the user can get a quote or get the product which they want to, which they should buy. They can fill it in a form, they can get a call from an expert, or they can chat with the bot. So as we can see that in total there are three features and the transition between those features. Now what happens in general scenario that getting a quote form is a bit longer. So what happens is the user starts with the form, but they end up selecting get a quote from an expert feature because that requires only 2 steps. So this navigation, and so a user can traverse between all these features freely. So now let's extend our example from of an e-commerce store to a concrete example of how Markov model can affect a user journey. So let's have an example.
I just wanted to launch a small poll here for our audience and try to understand how do they currently do user journey optimization for their website features. So do they use Markov modeling, or are they using A/B testing, or they also use some analytics reports from their analytic tools, right? Yeah, we have started getting in quite a number of answers. It is really surprising because almost all of the uh, audience are giving in respect like answers with equal categories, equal weightage to everyone. So why don't we build a Markov model based on this, right, Aditya?
Yeah, sure, Bismillah. That's an interesting stat there. We can see that almost 30 people, 30% of our audience is saying that they're using Markov models and A/B testing. So let's continue our example.
Okay, fine. I'm closing the poll now.
Thanks, Vishma. Thanks for the post. So let's continue with our example of an e-commerce store. So let's see that there is one customer named Jack who lands on our website. He uses navigation. After using navigation, he goes for search. Then he applies some filter, and then he finally converts. Well, that's great. A user is converting. That's fine. So let's try to visualize his journey into our model. So let's say Jack has started. Well, from start he goes to navigation, navigation to search, search to filter, and filter to conversion. So this is how his journey looks into the Markov model. Now, well, we don't have one customer, right? So let's move on to another customer. So here is Mia, who starts from navigation, and then she leaves. So let's try to see her journey visually. So here it is. So she starts, then she goes to navigation, and she left. Now there's another customer, Joey. So what he does is he's quite different than Jack and Mia. He, instead of starting from navigation, he starts from search. First he does some searching, then he applies some filter, and then he leaves. So let's visualize his journey. So he starts, then he goes for search, then he applies some filter, and then he leaves. So in total now we have 3 customers and their respective journeys, and we have 3 sort of a visualization for each of these journeys. So now let's consolidate all of this journey into one model. So this is how it will look. So we have feature as a navigation, search, filter, and conversion. And so user can start from navigation, search, filter, conversion, or user can leave from navigation, and many others. So there are various paths. So if we can see that we already have now states of our model. We have transitions or the paths between those features of the model. Now the only thing missing here is the rate parameter. So now we will focus on how the rate parameter is calculated. So if you can remember that there were out of the 3 customers, there were 2 customers who opted for the navigation, and then there was another customer who opted for the search. So which says that out of 3 customers, 2 customers have gone for navigation. That means the 66% of our customers have opted navigation as their first feature, and 33% of our users have used search. So let's try to put this into our model. So this will look like this. So now we have rate parameter for the paths between start to navigation and start to search. Now let's try to calculate the rate parameter for other paths as well. So from navigation, to 2 users who use navigation, from navigation 1 user or 1 customer, that is Jack, who went for search, and there is another customer, Mia, who left after the using navigation. So it makes us like 50-50%. So 50% of user used search and 50% of our user left. So let's put this into our model as well. So this is how the rate parameter for the navigation to exit and navigation to search transitions will look like. So now this is a simple arithmetic calculation, and we can do for all these transitions. For our example, where we have only three states and few selected paths, it is easy to do it with a pen and paper. But think of a scenario where we have a 10 to 15 features and so many paths between all these features. Then calculating the this rate parameter can be humongous task. So we need a computer program for that, and uh, that's simply by pen paper. It is a difficult one. So here we have a complete example, a complete example with the rate parameter for each of our transitions. So now we can see that the transition from search to filter has a rate parameter of 100%. Now, so if we go back to our customer journey, then we can see from search Jack has went for search, and after search he went for filter. Similarly, Joey has also used the search, and after search he has also used the filter, which makes that the users who use search quickly quickly after the search they use the filter. So which makes it 100%. So 100% of our user from search goes for the filter. Now let's with this rate parameter for each of our paths, what we can do is we can calculate the total probability of conversion of using these features. But if we can look closely into this model, we can see that there are two paths which can lead to a conversion. So there is a one path from start to navigation, navigation to search, from search to filter, and filter to conversion. Now there is another path which is from start to search, search to filter, and filter to conversion. So in total there are two paths for the conversions. So let's calculate the total probability of the conversion. So as you can see that the probability for the path 1 is 0.167. Now how did we arrive to this number? It's a simple calculation. What we did is we multiplied all the rate parameters of the transition of this path, which brings us to the number 0.167. We did similar for the path 2, and which also got the same number 0.167. Now if we sum up these numbers, we can have the total conversion probability of 0.33, which means that using this feature there are 33% of chances that user will be converted. With this number, what we can do is we can calculate the removal key effect. So what is exactly removal key effect? So the core of the removal key effect is to remove each of the feature from our model and try to measure its impact or its change on transactions. So in our own example, let's say we remove navigation, okay, and we try to check what is the change, or what is the impact on the total conversions. Now if we have, once we remove the navigation, we can see that there is only one path which leads to conversion, that is from start to search, search to filter, and filter to conversion. Now we do not have path from start to navigation to search because we have no navigation in our model right now. So if you could remember that in a previous model where we have all the features, we have the total probability of 0.33, which is now since we have only one path, that is search, from start to search to filter to conversion, which is now reduced to 0.167. So that is the total change on the conversion is that we lost our conversions by 50%. So that's a big number, right? So that is the removal key effect of the navigation feature, which means if we remove navigation, we are going to lose our 50% of customers. That's a big number. Okay, so what we are going to do, what is the next step in Markov Model is that we are going to calculate removal key effect for each of our feature. So initially we removed just navigation. Now what we are going to do is we are going to remove each of the feature consecutively, and we are going to check its impact on the total conversions. And that's how we can attribute our conversions to various features. Now that's a simple arithmetic as I shown before. So we already have prepared those numbers, and here they are. For a navigation, there is a 0.5 removal key effect. By that I mean is that if we remove navigation, we are going to lose our 50% of our customers. Similarly, for search and filter, if we remove them, then we are going to we are going to lose all of our customers. As if we can go back and see our model, that if we remove search, then there is no way for a user to do a transaction, or if we remove filter, then there is no way for a user to do a transaction. So which says that if we remove this, then we are going to lose all of our customers. But if we closely see these numbers, this probably doesn't sum up to 1. So to bring them on a 1 scale, what we can do is we can weight them. So by weight, I mean we are going to divide each of these removal effects by the sum of all the removal effect of all the features. By doing so, we can arrive at this number. So the removal effect of the weighted removal effect for the feature of navigation is 0.2. The weighted removal effect for a search is 0.4, and similarly for filter, that is 0.4. So now this probability does sum to a 1, and this is how we calculate the weighted removal effect. Now, so this is how we can attribute our transactions to various features. So 0.2 is attributed, so 20% of our transaction is attributed by navigation, 40% is attributed by search, 40% is attributed by filter. Let's try see now. Now we have a complete model in place. Now we'll try to see what are the insights we can bring out of this model, or what business decision it can impact. So before jumping into that, let's see what is the process of our achieving our Markov model. First, we need to extract data from BigQuery or Google Analytics.
Aditya, I'd like to butt in here. Actually, I just thought I'll launch one poll at this point of time. We just wanted to know what set of our audience use Google Analytics 360, the premium version, for your digital property. Okay. Meanwhile, Aditya, I wanted to know, you told you gave us a few good insights about the e-commerce store. So you meant to say that a filter is like 100%, importance of filter is like 100%. So if I remove filter, or if my filter is not working on my website, the feature, then I'm going to lose all my 100 customers. Is that what you meant by the Markov model results?
Yeah, exactly, Bishma. That's what it is mean by that. So if you let's assume that you have a filter that is a significant feature in your user journey, and if you're screwed up with your filters, then you're going to lose 100% of your transactions. So yes, that's a key important feature in user journey.
Oh, that's frightening. And it's similar with search also, right? Because internal search for an e-commerce store is very much important, as I see in my journey, correct?
Yeah, internal search is really a vital part of the user journey, and also you cannot expect substandard results from your search results. So from your internal search engine. So yeah, search is also an important feature in this user journey as well. So in our process to achieve to get the Markov model, what we need to do is we need to extract the data from BigQuery and Google Analytics. Then we need to do a feature selection process. Now this is the most important process when designing a Markov model, because we don't need to select the features which are obvious or which are direct in the user journey. By direct or obvious, I mean the features that the user are going to take, or without that the journey, the conversion is not possible. Then we need to explore those features. Otherwise, what will happen is we will have a one as the removal key effect for those features. Now it will show as an important feature, but if you see that, there will be an obvious feature of the user journey. So user journey feature selection is a key important step of the Markov model process. Now the next step is in designing a Markov model is that we'll calculate the removal key effect for each of the features, and we'll build a transition matrix. And with the help of the removal key effect, end transition matrix, we can bring out as many insights as we want, and we can incorporate all those insights and the outcomes of the models into the product development to see what changes it can bring, or how easy the user journey can be. Let's talk about the insights from the Markov model that we can get. So very first insight is that we can identify significant and non-significant features in the user conversion. So for example, let's say uh, we do a Markov model on a set of features, then we can easily, attribute, with the help of remote key effect, we can attribute the conversions to various features, and we can identify that which features are weak. And by identification of those, what we can do is we can make necessary changes into those features, and we could make the user experience as engaging as possible. Now, what the next step is that we can build a transition matrix. So what is a transition matrix? So here is an example of a transition matrix from one of our e-commerce client store, where we have selected some of 8 or 9 features from them, and we have prepared a transition matrix. Now, so how can we extract the insights after this transition matrix? So let's just try to figure out some of the key insights from this transition matrix. Very first is that we can see that 65% of chances that user will leave without using any of these features. So if we go back to transition matrix, and we can see that here that there are 65% of users are leaving without interacting with any of those features. So that's a big number, like 65% of bounce rate from these features. Now there's another important statistics coming out of transition matrix, is that there is a 58% of probability that user will exit after search. So if we go back to transition matrix, and if we see the search row, at the end of this, we can see that 57.81% of chances a user leaving after search. So that simply means is that our search results aren't optimized, and the users aren't getting the results as what they intend to get. So we need to optimize our search results, so for a better user experience. The another insight is that 49% of chances that user will check delivery after the recommendations, and 15% of chances that user will go back to recommendations after checking delivery. Now these two insights are really correlated. Now if we go back to this transition matrix, now we can see from recommendation there is 48.83% of users are going to check for deliveries. So what it means is that our recommendations are really interesting for the users, and once after seeing these recommendations, what they are going to do is they are checking whether these products are delivered to their area or not. But if we check the another insight from delivery checker, we can see that from delivery checker there is a 15% of users who are returning to recommendations. So which simply means is that once user go to recommendation, they find the product interesting, so they go for checking of delivery. Now they what happens there is that they do not find the product to be delivered in their area, and they return to the recommendations from delivery to see if there is any other interesting product for them. So which gives us a clear indication that we are not covering as many areas as possible in a delivery.
Oh, I would like to just butt in here. Yeah. Even I saw one insight. Just let me know if I'm right or not. If I am looking at the delivery checker feature and I'm seeing the people who are exiting, it shows 51.83%. That's a huge number, right? So it does indicate that I might not be giving it to all the pin codes that 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 the user is looking for, or maybe there is no faster delivery option for that. Am I right? Am I right here?
You're right on track, Vishmay. Actually, this is a pretty big number, and if you see that the user, after checking for delivery, there is a 51.83% are leaving. That simply means that our deliveries aren't covering the most areas. In fact, our deliveries are limited to very specific areas. So as a business manager, what I would do is I will increase the areas that I'm covering with the deliveries. So yeah, that's a good insight from the transition metric. Thanks, Vishmay. There is another important insight from that, is that only 17% of chances that user will convert after using promotions. So let's check this out. So what happens is, if we see from promotions, there is only 17.45 people, 45% of users are actually doing a conversion. That means that when a user applies a promotion, it shows his or her high intentions of conversion. But what happens is that they find this promo code not so satisfying, or they are invalid, or they have some hidden terms and condition applied. So with that, they are not fine, they are not converting. So that's a big number. I think when you are promoting your coupons and promotions code, you should make sure that they are actually bringing a high number of conversions. So that is another key number that the business manager need to look into. So the transition metric doesn't stop here. We can find as many insights as we want to, and even the Markov model doesn't end here. But so there are several few advanced cases with the Markov model. So here are some of them I have listed, and I will be covering each of them in the details. So very first is that the different Markov model for different types of user. So be it an app or be it a web, you have different types of user. Like we have new users, returning users, frequent buyers, and infrequent buyers, and many others. Now what happens is that the user journey of each type of these buyers are different. For an example, a user journey of a new user will be longer than the returning visitor, simply because a new user is more concerned about the returning policies or FAQs or security. So obviously the new user is going to check for, he's going to use more features than the returning visitor. Similarly, frequent buyers have a comparatively shorter user journeys than infrequent buyers as well. So designing a one Markov model for all of them wouldn't give us the concrete insights for this type of user. Some of the features that might be important to new users may not be as important as to returning users. Doing the whole analysis for in a one and with a one Markov model wouldn't make much of the sense. Instead, it will overlap the insights. So what we need to do is we need to design a different Markov model for each type of the users to get a concrete insights for the various types of users. Similarly, we can design a Markov model for an endpoints which leads to no conversion. Now, in our example, we designed a Markov model with an end goal of a conversion. But in the other way, what we can do is we can design Markov model which leads to no conversion. So what that will help us in identifying the spots that leads user to the exit, and we can attribute those exits to each feature, and we can optimize our features in a way that reduce the number of users leaving the property after using of those features. So this can help in making the whole user experience more engaging. Now the next the next advanced use case for the Markov model is that we can attribute revenue and cost to the features. Let's extend our example of an e-commerce store where we have this weighted removal key effects for each for three of our features, that is navigation, search, and filter, and we have 0.2, 0.4, and 0.4 weighted removal key effects. Now let's assume that we have an average order value of 600. Now we can attribute this 600 to these features. The arithmetic is very simple. We divide 600 based on the ratios. So the 600 is 120 out of that 600 is attributed to navigation, 240 is attributed to search, and 240 is attributed to filter. So it is just a ratio distribution between of the 600 to the features. So this is how we can attribute our revenue to the features. Now the next is the hidden Markov model. Now it is an interesting variant of a Markov model where we try to identify the unobserved states of the system, or the features of the system is not there exactly, but user is led to those situations. So what we can do is we can identify the features which leads user to this unobserved state, and we can identify the removal key effects for those features, and we can attribute revenue and cost to it. So hidden Markov model is help us in identifying unobserved states of the system. So yeah, so this with this advanced segments and example, this brought us to the end of our presentation. So we'll be answering questions right after this.
Yeah, thank you, Aditya. We'll just go ahead and take some questions for now. Just a reminder, please be sure to type your questions into the question box below in your GoToWebinar control panel. Uh, yeah, and okay, we have started getting in some questions. Ashley is asking, what is the ideal number of features that one should take for Markov modeling?
Okay, so that's a good question actually. So what the ideal number of features are not it cannot be generalized or cannot be specific to one range or one number, but it greatly varies depending upon the business application. So we cannot be sure we cannot be sure upon, or we cannot be agree upon one sequence, but the ideal number has to be between 10 to 15 features is a good number to start with.
Reno, he's asking whether this current model that you were talking about, the Markov model, is it a SaaS or is it internal?
So right now the Markov model that we design is not available as a web or a SaaS product, but it is mostly an in-house analysis that we do. So right now there is no SaaS available for to use. Instead, we carry out this whole analysis internally, and right now we are in the planning to have this done on the web.
I think Reno is quite interested, so we'll be sure to reach out to you via email. Maybe we will be able to do a Markov model for you. Okay, there's another question that he is asking. If there is a repetition of state, how does it affect the model? I think he must mean that there were the states or the features. So say if A goes from A to B and from B to A, whether it affects the model. I think he's indicating that. So would you like to answer that?
So that's actually an interesting question. So from if a user is going from the same feature to same feature again and again, then it shouldn't be considered in our Markov model, as it will increase the removal effect for this feature, and it will make it wouldn't it wouldn't helpful in bringing insight. And if a user is from feature A to feature B and then feature B to feature A, then that path is actually a legit, which gives us which brings us to what happens is that a user is actually returning to the feature A after using feature B. So that's a legit path, and we can we should definitely include that into our model.
Yeah, Lars, I have questions from Lars. He is asking, what order of a Markov are you using? I guess it's just of order 1. Would you recommend using Markov models with higher orders?
So yeah, this is a good question, Lars. Actually, so yes, exactly as you are saying that it is the order of the current Markov model is 1, but yeah, it is a good to use a higher order Markov models. We can obviously go for order of 2, order of 3, in which we can attribute the previous states of the model for the user's current state. So yes, we can use a higher order Markov as well.
Yeah, thank you, Aditya. There's a question from Colin. He asks, how much do you charge to look at website for Markov model? Yeah, Colin, we'll be sure to email you with our costing. It's actually not a SaaS-based pricing, so we can just do a personal audit of your website, and we'll be able to give you a pricing for that. What is the frequency of modeling that needs to be done?
So the frequency of model depends on how quickly you implement the insights that you receive from a model. The ideal frequency should be like 2 months or a quarter. But what happens is that once you have a Markov model, you can bring out the insights. Now with those insights, you need to implement those insights into your product development. So if whatever changes you get from the insights, you need to incorporate those into the development. Once they are incorporated, you need to remodel for the Markov and for the features, and then you need to measure the efficiency of those features and the changes that we have brought into the picture.
Aditya, for answering. Lars has another question that has come up that I can see. Actually, there are a couple of questions. We may not be able to answer them in this during the webinar because as we are reaching to us end. Okay, but I just read the last question. I think that has popped up now. Yeah, thank you. He has asked very nice. He has said very nice webinar. Where can I get your slides? We'll be sure to send you the webinar recording as well as the slides to you to your email inbox. So you need not worry about that, Lars. Thank you for being a good audience today and asking a lot of questions. Aditya, is there anything else you wanted to cover before a wrap up? Okay, so here's our one more poll that I wanted to launch. It's on the base of our next webinar. We have an upcoming webinar on UI UX optimization. It's on what are the 5 most common user experience mistakes and how do you avoid them. It is scheduled on September 28th. Its time is 5:30 p.m. IST. The speaker is an UX expert who has 4 years of experience. So her name is Riddhi Mehta. If you say yes today, we would definitely do a monitoring. I will definitely send you the email as well as add you to the webinar without you doing all the registration, which means like we are going to simplify the user journey, removing one of the states of our user journey. So Aditya, I think I just used your Markov model for webinar registrations, right?
Yeah, that's the applied Markov model in daily life. Nice, Bismay.
Thank you. Uh, okay, so we have got a fair amount of answers for the poll. I think I'm just going to close it in next 2-3 seconds. So our next webinar, as I said, it is on UI UX optimization for our website features. It is going to be taken up by Riddhi. Uh, we will look forward to see you in that webinar. Thanks a lot for joining us and staying till the end of the webinar.